So welcome to all. Today I Dulvesh will start a new topic which we are going to study, that is cryogenic engineering. This is the part 1 of the topic cryogenic engineering. So the word cryo and genic has derived from a Greek word. So Greek word, not kyo, it is cryo, which means very cold. Okay, so cryogenic engineering is basically a study of cold temperatures and its machinery. Okay, cold temperature and its machinery. So till the temperature of 123 Kelvin, we call it as a refrigeration, normal refrigeration. Okay, where will we store food? Where we store food. Okay, but when the temperature drops below 123 Kelvin, that comes under the part of the cryogenics or the cryogenic engineering. Okay, so today we are going to learn this cryogenic engineering, that is the temperatures below 123 Kelvin. Okay, so how we will identify the temperatures below 123 Kelvin? With normal temperatures, for normal temperatures we use thermometers. It can measure up to 0 degrees Celsius, but 123 Kelvin is below 0 degrees Celsius. So how will we measure? So for that we use silicon diodes and platinum 100. Silicon diodes and the platinum 100. Okay, silicon diode are very expensive and measures up to 1 Kelvin, that is it can measure accurately up to 1 Kelvin. So how does a silicon diode look like? So silicon diode is basically a thing like this. This is the wire and it has a head like this. Okay, so forget that, it is not a part of concern for us anymore. So moving forward, so what is platinum 100? Platinum 100 is used to measure the cryogenic temperature. It measures correctly up to 50 Kelvin. But how does this platinum 100 measure the temperature? For measuring the temperature, we measure it through the resistance method. So what does the method say? The platinum 100 has a resistance of 100 ohm at 0 degrees Celsius. So when the temperature will drop more below the 0 degrees Celsius, its resistance will also decrease or increase. So in that manner we measure the temperature. Okay, so moving forward, so why are we learning this cryogenic engineering topic? So for knowing the purpose, we must know the applications. So what are the applications of the cryogenic engineering? We are going to learn the application space and the application in the mechanical engineering also. Okay, so first the applications in space. There are three basic applications, which is the rocket propulsion, cooling of infrared sensors, and the space simulation. Okay, so first the rocket propulsion. So rocket propulsion, liquid H2 as a fuel is used for rocket with O2, that is H2O2 fuel cell. We know H2O2 fuel cell, it is used as a fuel for the rocket. Okay, so the liquid H2, for the fuel cell you will need liquid H2 and liquid O2. H2 is liquid at 20 Kelvin and O2 is liquid at 90 Kelvin. These are the cryogenic temperatures. How we will go to such a low temperatures to obtain this liquid H2 and liquid O2? With the help of cryogenic engineering. Okay, so hence for rocket propulsion we need cryogenic engineering. In space we launch satellites. Okay, we launch satellite. Why do we launch satellite? To get images. We get images through infrared sensors, telescopes, and cold probes which are attached to the satellites. Okay, so basically lower the temperature, the better image we get in space. Infrared sensors capture image at 80 Kelvin or the temperatures less than that. And for getting such low temperatures in space, we need miniature cryocoolers for satellite. So what are the cryocoolers? Cryocoolers are the devices which give extremely low temperature. extremely low temperatures. Okay, the cryocoolers give extremely low temperatures. One such example is the Stirling cooler, which has a cold finger. At the tip of the cold finger, we get the low temperature. Okay, so next part is the space simulation. We send astronauts to the space. For sending astronauts to the space, the astronauts must be habitual with the environment of the space. For that, we create space simulation. To create the space simulation, we need the cryogenic engineering technology. Okay, so to stimulate the cold at Earth, we need liquid nitrogen. For liquid nitrogen, we will need cryogenic engineering. At the space, temperature is less, up to 4 Kelvin. Okay, so for that, we will need to make the temperature below 4 Kelvin on the Earth. Again, cryogenic engineering. Pressure is less, we need to create the less pressure. Vacuum is there in the space, as there is nothing, there is a vacuum in space, so we create the vacuum using cryo pumps and the turbomolecular pumps. Okay, so that are the applications in the space. So let's see the applications of cryogenic engineering in mechanical stream. Okay, so there are three basic applications in mechanical, that is the magnetic separation, heat treatment and recycling. There are many more, but we will learn these three. Okay, so let's start. So magnetic separation. We know that in various metals, various ores and various other things, there are various impurities. We need to remove those impurities. Okay, we need to remove those impurities. But how we will remove those impurities? We will use the magnetic separation. But how? See, there is a clay called as the kaolin clay. Okay, the brightness of the kaolin clay is enhanced by the magnetic separation. Okay, we know quartz. So for improving the quality of ultra high purity quartz, that is to get the ultra high purity quartz, we use magnetic separation. Okay, but how? For such magnetization, that is for magnetization to a very high degree, electromagnets cannot be used because the transmission losses will be very high. Hence, we get the temperatures of cryogenic pipe, that is, the cryogenic temperatures are used for such high quality magnets to give the magnetic separation. Again, we use heat treatment. So, what is the heat treatment? There are various tools, die castings, dies, forgings, jigs, fixtures, all of the mechanical kind of stuff. For increasing their life, we use cryogenic heat treatment. That is, we give them extreme cold conditions which increase their lifetime or lifespan. Okay, also if we give cryogenic treatment to the guitar strings, its lifetime increase for 4 to 5 times, and tuning is not necessary then. Tuning is not necessary. Okay, again in recycling we use cryogenic temperatures. How? It turns scrap material to raw materials by subjecting to cryogenic temperatures. How? We know rubber. Rubber is very flexible. But when subjected to cryogenic temperatures, rubber gets rock hard. That is, if we dip it in N2 bath, that is liquid nitrogen bath, rubber gets rock hard and brittle. We can powder that rubber. It becomes so brittle. Okay, so it becomes rock hard, and in powdered form it can be easily recycled. Again, for PVC, that is polyvinyl chloride, that is the PVC pipes. The PVC pipes, other PVC materials and rubbers are recycled using the cryogenic temperatures. So now we have learned the application in the space and in mechanical engineering of the cryogenic temperatures. So in the next part we will going to learn some of the properties of materials when they are subjected to the cryogenic temperatures. Thank you for watching this lecture. If you liked this video, please subscribe to our channel and share this with your friends for enhancing their knowledge. Thank you very much.